Welcome to the next video of Open Commissioning. In this video, we will model this little example station with common assembly line components like conveyors, a lift, indexing units, and stoppers, and so on, completely from scratch. So we will begin only with the CAD data and work our way through modeling every component, adding the devices that control the system, and in the end, we will be able to manually move this payload here around this line, stopping it, and so on. So this is a little longer video because I will show everything from scratch. You can follow it along, but we are also providing you with an example project that contains basically this model like this, where there's no geometry inside because we can't share it, but the same functionality and the same open commissioning components configured in the exact same way. So you can try this out for yourself. Okay, so I will start with a completely fresh Unity project and show you how we go from there. Okay, so here I have a fresh Unity project. I just created it and there's nothing installed yet. And now I have to install the dependencies and the Unity package for open commissioning. So I go to packages, show in Explorer, see the manifest JSON. I open this, then I go to the open commissioning GitHub page, copy the dependencies, add it. And I also can copy the URL for the Unity package of open commissioning and just add it here. Save this. Now the package manager should install this automatically. Okay, this is done. Took like a minute or so, and now we have the open commissioning package installed. When we look in the package manager, we see that we installed all the relevant dependencies and also package for open commissioning itself. Okay. Next thing we need to do is one little configuration. So we go to open commissioning in the menu, go to settings and apply the default layers. This creates the required layers and the collision matrix for open commissioning to work. So this is relevant later when we model transport layers or stoppers and so on, that they are existing and configured. You can check this out here in project settings. Under physics, you see now there are a few new layers created, and also the collision matrix is configured in a certain way. Okay. Okay, so let's begin with modeling a few components. Okay, the first step is always to import the 3D models, the CAD data, into Unity. In this example, we are using models from the Bosch transfer system TS2+. You can get the CAD data from their website here and import it into Unity. I was using the Pixies plugin to import the model and export it as an FBX, and I put the FBX files into this new project in the assets folder here called CAD Data. So here I have the 3D models of the units that I'm going to model now. Okay, so let's begin modeling the conveyor unit here. So let's put it in our scene. This is just the raw CAD data and nothing else. We'll start by creating a new folder in our assets called prefabs, because we will model every component here as a prefab, so we can instantiate it multiple times in the final model. And this is a very good practice to make the models reusable and can using the Unity prefab system. Okay, so let's create a new prefab from this. Just first, let's unpack this and create a new prefab. Okay, now I go into And we will begin by structuring this data a little bit more, so it's a little bit cleaner here. For this, I always add a new hierarchy tab, put it to the side here, lock it, and now this one doesn't open the hierarchy tree, so I can work here a little bit more comfortable, so I don't have to scroll all the time. So the first thing I always do is just create a new object called geometry, and I just put in every mesh into this node. So then I can delete the old one. I just have a clean object with just the CAD data in here. So yeah, this is obviously the conveyor unit that we are going to model. So in the end, we want to transport payloads. The pallets will be transported along the conveyor here. So the first thing I'm going to model now is the transport surface on which the payloads will be transported on. I create again a new game object, and let's call it transport. And I will add the component transport linear to it. So this is from Open Commissioning and allows us to model exactly those kinds of transport surfaces. So what we see here, it already created a box collider and a rigid body. The outline of the box collider will be the surface on which the payloads will be transported on. So the direction is always the set direction for transport linear objects. So we need to rotate this to match the geometry. And we can also specify the length and the dimensions of the surface in the inspector window here. So in our case, we have 1.5 meters of length. The width is 0.24 meters. And the height is, 0.1 meters. That's okay in this case. We also can check to show the gizmos. Now we see the dimensions of the transport surface a little bit better with this outline here. Okay, so now we have the surface modeled where the conveyors transported on, but we have to reference an actor to it. So you can think about it like the transport linear surface is just a way to model that the payloads can sit on it, but without an actor, they can't be moved. We have to reference an actor for this. In this case, the actor is there's a drive here, so we add a new object called drive. So I added a new game object, and we add a new component called drive simple. This is also from Open Commissioning and allows us to just two signals forward and backward to rotate a drive forward and backward, basically. Let's go back to the transport surface and reference this drive to the component. Just drag it into here. And now the transport surface here is controlled by the drive. So when the drive is providing a target value, it will move payloads on this transport surface. Okay, so let's save it. This is basically done. Go back and continue modeling the payload itself to test this out. Okay, so let's model the payload, which is going to be based on the geometry of this carrier plate. Okay, so let's create a new prefab for this again. And start editing it. So again, what I'd like to do is always make a new object geometry, and I just add everything in there. And now I have a clean object with just one node. To model this as a payload, I just have to add the payload component. from Open Commissioning and edit the box collider to match the geometry of the part here. So in this case, the dimensions are this. So I edited the dimensions of the box collider to match the geometry, and it is also important that the bottom edge of the collider starts exactly at 0. So I specified the center accordingly so that the bottom edge is exactly at 0. Okay, let's save it. Let's go back. And now when we enter play mode, we already see that the payload here is sitting on the surface. We also get a little error that we will fix in a second. But when we start the drive of the conveyor with override and forward, we will see that the payload is now being transported on the surface. So it is receiving a value from the actor and it's transporting the payload in the forward direction. We can also move backwards. So we see that the basic functionality is modeled. So let's quickly fix this error here. What we need to do is add a new object to the scene with called pool with the pool component of Open Commissioning. This is used to manage all the payloads inside the scene. And we have to specify a payload list with every possible payload that can be existing in the scene. So let's just add our payload here, clear it, and now when we start again, the error is fixed basically. Okay, great. Yeah, let's put this a little bit more forward here so it just doesn't fall off so easily. Okay, great. Okay, the next thing I want to model is a little sensor that is sitting on the surface here that can detect whether a payload is above it. So let's create tab, call it we have the CAD data for the sensor holder here and also the sensor itself. Okay. Unpack those. And let's make a new geometry object. Make it a little bit more clean again. Okay. So now I have just the model of the sensor here. So let's add the sensor component of Open Commissioning. New object called sensor. And let's add the sensor binary object to it. Again, we see a box collider was added and the sensor binary component. The box collider is basically the detection zone of the sensor. So let's rotate this here and set the length not to 1 meter, but maybe to 2 centimeters. This is probably okay. A little bit more, maybe 3. Okay. And we can also add the sensor beam component, which will visualize the state of the sensor basically. Okay, let's save it. Back and add it to the scene here. For now, this is not that important where exactly it is located. It's just under the payload. This should be okay. And when we now start the simulation, we see the little sensor beam, which is green at the moment, but when we move the payload, we will see that it will turn red, which means that it is detecting something. You can also see this in the inspector here, that it is colliding with something and receiving a value. The payload away again, we see there's no collision and no value. Yeah, when we start the drive of the conveyor, of course, it will move the payload, and yeah, the time that is over the sensor, of course, it will. Yeah, we can use this control program to detect, of course, whether there's a payload over it. Okay. Okay, next let's add a little stopper cylinder that sits on the conveyor and can extend and retract and can collide with the payload and stop the movement of the payload when it's colliding with it. Therefore, we can control the flow of the payloads on this conveyor. So we already have the geometry for this. Let's create a new prefab for this, start modeling. Okay, so this is the geometry of the cylinder. So in the real world, this little part will extend and retract and collide with one side of the pallet, and therefore stop and also release it. Yeah, this model here is not ideal because the whole cylinder body and also the part that is moving is just one mesh. So we need to model a little additional geometry to visualize the movement because we don't want to move the whole cylinder. So we have to add a little helper geometry. But first, let's create a new game object for the geometry and put it all in so we have a little more clean. Okay, so as I said, let's add a little cube for this. Let's make it way smaller. Put it at the correct position. Scale it a little bit more. Yeah, so this looks okay. Okay, so this will be the object that will move up and down and collide with the payload. For now, let's put it in the down position. So when we extend the cylinder, it will move up. To be able to collide with the payload, we have to specify the layer for this cube to stopper. So this box collider will then only collide with other stopper colliders that we will add to the payload later on. But let's continue modeling the movement of the cylinder here. So whenever we want to model any kind of movement that we want to control with something, we first have to define an axis on which the movement is performed on. So let's create a new object called axis, but let's put it in here. And let's add the component called axis. So when this component is receiving a value from an actor, it will perform the movement along the axis defined here. So in this case, we want the cylinder to move up and down in the Y direction here. So we specify the direction in the settings here as Y. Type is translation. And the factor here we will set to 001, so we can receive the target values in millimeters. So when we specify a value in the actor, it will be read as millimeters and move the object accordingly. So when it is receiving a value, the object here will move up and down in this case. So when we want to move the collider body with the axis, we have to make this as a child of this axis component. So now when we move it up and down, we see that the little helping cube here moves up and down as well. Next, we need an actor for this axis. So this will be a cylinder here. Let's create a new object called MB cylinder. And let's add the cylinder component to it and reference it as the actor for this axis. So I go back to the axis component and drag in the cylinder. And now when the cylinder is extending or retracting, it is sending the values to the axis and it will perform the movement in the simulation. Here we need to specify the limits. At the moment it is from 0 to 100 millimeters. Let's change this to maybe 10 millimeters. This should be enough. Okay. Let's rearrange this a little bit and save it. And now we can test it. So let's start the simulation. Focus on our cylinder here, to the stopper cylinder, go to the cylinder component, click override, and plus and minus, and we will see the axis is moving the little block up and down exactly as we intended. So we see here it is actually moving the axis component here. So at the moment it is extended to 10 millimeters. So this is here in the position, it's visible as well. And when we down, it go back to 0. So this is a very fundamental way how to model movement in open commissioning, is that you always need an axis and an actor. Okay. So let's position it. Oh, no, let's stop the simulation. Position the stopper at a suitable position. Maybe here. Let's start the simulation. Extend the stopper cylinder and start the drive for the conveyor. And we see that the payload isn't stopped by the stopper, although it is extended. This is because right now the payload here, the pallet, doesn't have a collider that can collide with the stopper, so it is completely ignored. So we have to add this next. So let's go back to our pallet object, to the prefab, and add the collider. So in real life, we have on the other side palette, we have those areas here that collide the stopper, and also those little grooves that are spared where the stopping cylinder goes through, so it is only stopped at one side, and the other side it can pass. Okay, so let's add some new objects for those colliders. So let's model them very quickly. Let's call them collider. Add a new boxed collider and set it to the stopper layer so it will collide with the stopper. Right now the collider is way too big. Let's change it here. Okay, so I added 4 stopper colliders for each side here. So those will collide with the stopper under the conveyor, and in this groove here, it will let it won't collide, so it's through. Okay, so let's save it. We now see the benefits of modeling with prefabs. Change it in the prefab, and this is instantiation of it. It will automatically update the changes here. So we see the object here in the simulation in our scene also got updated with the colliders here. So let's start it. Let's try again. Let's send the stopper and start the drive. Now we see it will. So we saw that it was colliding, but also it was not staying on the conveyor and like moved around it. So we need to modify the surface and also the payload to be guided. That means that it will always stay on the transport surface and not rotate around anything. Okay, so let's go quickly to the conveyor unit, to the transport surface, and just add one configuration here, which is the option is guiding. So we set this to true, and now the surface will guide any payloads that are on it and won't allow this kind of rotation around it, basically. We also have to add another component to the payload prefab here, which is called guided payload. This now enables the guiding transport surface to recognize it and keep it on its surface. So let's start again. One last time. Let's extend the stopper. Let's start the drive. And now we see the pallet is stopping. It is colliding with the stopper cylinder and also not wiggling its way around it here. We can also retract the cylinder again, and we will expect that the pallet is again because it's not stopped anymore. So let's do this. And yeah, exactly how we envisioned it, the pallet continues moving on. Okay. The next module is the indexing unit, which sits under the conveyor here and can lift up a pallet to index it, to bring it into a certain position here. So let's make another prefab for this and start modeling. Again, geometry. I mean, this step is not technically necessary, but gives it a little better structure. So what we want to model is that this part here can move up and down with a cylinder. So we do the same as for the stopper cylinder. Let's start by adding the axis component. Okay. Add the axis. And this is also moving in the y direction and is a translation axis. So we change it here. And again, we put the factor to 0.001 to make it able to receive millimeters as a target value. Okay, inside the axis, we need some geometry. So part here will be moved with the axis, and those two here, put them as child objects of the axis. Them their own parent object. Okay, so we see now when we move the axis component, every required geometry is also moved with it to visualize the movement correctly. Okay, next, of course, we need the cylinder again. So let's edit. Let's call it indexing cylinder. Let's add the cylinder component. The limit should, let's see, yeah, I guess like 30 millimeters is okay. And let's reference this as the actor for this axis. Okay. So right now we're just around geometry, but we also need a surface on which payload will sit on. So it can collide with the payload and pick it up basically. So under the axis component, we add another object. Let's call it surface, and let's add another transport to it. So the payload can sit on it basically. Okay, so position it a little bit better. Let's this is okay. From the position, then the length is the width is, let's see. Yeah, this should be okay. The height is like this, it's okay. And let's also position it so that the surface edge is on the edge of those cylinders on which the will sit in. Okay, and we also set it to guiding, so the payload is fixed on this surface basically. In this case, we don't need to reference any actor because we don't want to move the payload around the surface. It's just there, so it can be lifted up and down, and this is done by the. So modeling for this is basically finished. Let's go back, position it a little more realistic. So here, I put it. This should okay. And let's start the simulation. Let's move the payload over it. Yeah, this should be okay. And let's extend the lifting cylinder. So we see the payload is being picked up. And it is on the surface now. And when we put it down, it is standing on the surface layer again. So to confirm this, we can also turn on the conveyor, start it. So now we see that it is moving. but the payload obviously is not moving because it's lifting up in the air. Let's down. And as soon as it touches the surface of the conveyor, of course, it starts moving. Okay, so the last unit we are going to model is the lift unit. Looks like this. Basically, a conveyor that can transport the payloads here that can move up and down. So it can bring the whole conveyor to a different height, and there's another linear conveyor connected. It can bring the payloads to a different level, basically. So let's begin modeling. Prefab. This one, and start modeling. And again, first step, let's create a geometry object where we put in all the geometry. So basically, there's this structure inside that moves up and down. So we need to define an axis for this. So begin by modeling the axis. Add the axis component again. It is again a translation axis in the y direction, layer here up and down. And now we can put in every geometry that has to be moved up and down to visualize the movement. So let's create a new object here. It's geometry. And inside this, we put every object. So yeah. So way to select this. So when we use the box selection, we can already get most of them inside. Okay, also part of this structure and those blocks here. Okay, so when we move the axis here, yeah, this looks good. Yes, okay. We can concentrate on modeling this by hiding the rest of the geometry. Okay, so this axis is an actor because we need to move it, and this will be a drive. So let's call it MA lift drive, and add a position control drive here. So we can specify a target here when we override it, and it will move axis to that target again. So let's reference the actor in the axis. Yeah, let's also put in the 001 factor so we can millimeter target values of the axis. Okay, let's quickly test this. The simulation started. Go to the drive. Let's maybe put in 100. Let's see it is moving up. Yeah, 1000 is probably too high. It will go through the roof. But okay, we see the movement is modeled correctly. Let's continue modeling the conveyor inside the lift here. Okay. This. Okay. So inside the axis, because the surface, the transferred surface also has to be moved with the axis, we add a new object, surface, and add transport linear component. Wait. Okay. Let's position it correctly, rotate it the right direction. The length is, yeah, maybe 0.57, 4 or something. Yeah, this should work. And the height, the position here, let's it like on the edge of those rollers, basically, I guess. Okay. The height is okay. Keep it the same as in the conveyor. The width is 4 again. This also guiding. We also check the is dynamic option. This makes it a little more efficient when the whole surface is moved. So in this case, because it's on the axis, it is moved around. We check the is dynamic option, makes it more efficient to move this around internally in Unity. Okay, I think this we can also hide, make it look clean. Okay. Okay. Let's also add drive for the conveyor. Let's conveyor reference this as the actor of the surface. Oh, yeah. I need to add the drive simple object. Now it is an actor and can be referenced in the. No, this is the wrong actor. Yeah, this is the. Okay, so now the conveyor drive is driving the surface, and the lift drive is driving the lifting axis. Let's rearrange this a little bit. Okay, great. Okay, let's test it. Add a payload to the lift. Start the simulation. Should fall down onto the surface. It does. Let's drive the conveyor. Okay, forward and backward. It works. And also drive the lift drive. Let's say 500. Then it will lift up the conveyor to that specific height. Okay, so now we have all the units modeled as prefabs. Let's begin assembling the demonstration line to finish the little model. Okay, so now that we finished modeling every unit for our little assembly line here, let's scene and model the complete line. Yeah, let's start by creating the pool object, adding the pool component and referencing payload. Okay. Okay, so our little demo line here will consist of a lift unit. Fab I'm going to instantiate here. Let's call it lift 1. And at the moment it is in the down position, so I want to add another conveyor here at that height. So I'm going to select the surface object here and add the conveyor prefab. And since I added it as a child, which gets positioned per default at 0, 0, 0, it is exactly at the same height. So I can rotate it and position it roughly here so that there's no big gap between those. The lift is moving up. It will be traveling 400 millimeters. So I'm going to add another conveyor unit at the same position as the first one, but 400 millimeters above it. One conveyor and the second one there up. Okay, so to the upper conveyor, I want to add the indexing unit. Position it also roughly here. That looks okay. And to stop the payload for the indexing, I'm going to add the stopper. Yeah, here this looks good. And before this, I'm going to add the sensor we modeled, also positioning it kind of roughly, just demonstration. Yeah, that looks good. And on this side, I will finish the loop here with another, drag that in, move it up here, rotate it. So positioning it so that there's no big gap between here. Let's call this lift 2. Okay, let's add payload, test this, and we are ready to start the simulation. So you saw it is very easy once you created all the prefabs to just pull it into the scene, position it, and therefore modeling the machines efficiently. And also because those are all instantiated from the same prefab. If you want to change something on the conveyor, for example, if you realize that the length is not ideal or the positioning of something is not ideal, you can just change it once in the prefab and it will reflect these changes in every instance of the prefab. Okay, let's start the simulation. And I will manually control all the devices, the cylinders, the drives, and so on to move the payload around the line one time to verify that everything is modeled correctly. So the first thing I'm going to do is extend the stopping cylinder, start the conveyor drive of the upper conveyor, and we see the reaches the stopper. Of course, it will stop moving and it's stopping. The sensor in front of the stopper is getting a signal, indicated by this red here. Now the payload is above the indexing, so I can this standing the lift cylinder of the indexing unit, and I see it will pick up the payload, put it down, but it's of course still stopped by the cylinder. Let's retract this and move on. So we're reaching the end of the drive here, of the conveyor here. Let's stop it. Let's move to the lift drive, write it, send it to millimeters. Now it's moving up. Let's start the drive of the upper conveyor again. Now it's reached the end and is on the transport surface of the lift. So let's start drive, pick it up inside the lift. So it's now on the conveyor of the lift. Let's send the conveyor of the lift down to 0 and push it next conveyor. Now it's on the next conveyor, but drive isn't running. So let's start this. Now in the other direction, of course. Now it picked up the payload and it's moving on the down conveyor. Now it will move to the conveyor of the first lift. Pull it in. Push it up. And move it out of the lift, stopping at the stopper again. So as you saw, I controlled everything manually with the override functions of the devices. But in the end, of course, this is very tedious, and this is why we do automation. And later we will connect this to a control program that controls basically this flow. The C. So it's all an automatic, and we don't have to do anything manually. As you can see, you can basically, like in a very basic manual mode, already test the model correctly, like the material flow is working correctly, the kinematics of the machines are correct, and after that you can connect the PLC program to control it in automatic mode. So now that we confirmed that everything is working correctly in principle, we can now like make this visually a little bit more appealing by assigning different materials to this CAD data, which I did now, so you can differentiate between the different components a little bit better. But yeah, this is just a visual feature and also making it look a little bit more realistic. But speaking of looking realistic, we want to provide you with this demo project here, but we can't share with you the CAD data. So I created the same model basically, but I removed the geometry and placed it with just very simple cubes. And you will be able to download this this Unity project with this scene here and check everything out for yourself. So there are the exact same components with the exact same devices inside that I modeled before, just the geometry is replaced. Cubes. So there's no difference. You can test everything I showed here for yourself. And we hope that you get value out of this. And we thank you for watching, for your time, and we will see you next time. Bye bye.